Now we'll move on to problem 2 on page 150. Marisha?
Show that games of the prisoner's dilemma can be stated in entirely non-numerical terms by referring to the player's preferences for outcomes.
Okay, this is to show you that the prisoner's dilemma is a structure that has not to do with any specific choice of numerical values, but only a pattern of those particular values represented in the agent's preference ranking. Remember, the structure of the prisoner's dilemma arises when you and your partner share the following preference for outcomes. You have to prefer the outcome of don't confess, and your partner of the outcome of you confessing and your partner don't confessing. That's got to be the most preferred outcome for you. Of you confessing and your partner not confessing. Where the next preferred outcome for you has to be the outcome of you both not professing. The next preferred outcome on your list needs to be the outcome of you both confessing. And the least preferred outcome on your list has to be the outcome of you not confessing and your partner confessing. And if your partner has exactly this same structure for his or her outcomes, we will have the structure of the prisoner's dilemma. So if we just give this a value of 4, this a value of 3, this a value of 2, and this a value of 1, purely on a preference ordering, we will show that we have the prisoner's dilemma. Okay? The outcome of you confessing and your partner not confessing that's your most preferred outcome, and that's your partner's least preferred outcome. The outcome of you confessing, you not confessing, and your partner confessing, that's your least preferred outcome, and your partner's most preferred outcome. That's your minus 25, his or her minus 1. The outcome of you both confessing, 2, and the outcome of you not confessing, 3. No matter what values you fill in, so long as the preference rankings for both you and your partner have this particular structure, no matter what interval scale values you put in, you will have an example of a prisoner's dilemma, because once again, this will be the only point at Nash equilibrium, right? Because you will have no reason to switch from your third preferred item to your least preferred item. Your partner will have no reason to switch from his or her third preferred item to his or her least preferred item. And most importantly, this point will be preferred by both. 3 as opposed to 2. That's a higher ranking to 3 to 2, but this point will not be in equilibrium because you will have reason to switch your choice to get your most preferred item unilaterally. Your partner will have reason to switch his or her choice to get his or her most preferred item unilaterally. And so while this point is preferable to this point on both of your scales, nevertheless, it is not the point that any rational, self-interested individual will reach unless you two can somehow coordinate your strategy to get on this point and stick to the coordinated agreement and not double-cross each other.